Welcome to AminAcademy.com. In electrical engineering, let us discuss about division of current in parallel circuits. Here, the parallel circuit is given. The current division rule states that the current in any of the parallel branches of a parallel circuit is equal to the ratio of opposite branch resistance to the sum of all resistances multiplied by the total current. Let us discuss this statement now. Here, the voltage supply is here and current passes through current I. The terminal point A and B is here. Here the first branch is I1. Current I1 is passing through. Then this second branch current is I2. Here let it be here resistance 1, resistance 2. By Ohm's law, here I1 equal V by R1. Here in parallel circuit, voltage is not distributed. Voltage is same in two divisions here, and I2 equal V by R2. Now dividing both, that is I1 by I2, I1 over I2 equal that is V by R1 over V by R2, which is equal to R1 by here, which is equal V by R1 into R2 by V1, R2 by V, which is equal R2 by R1. Now that is, we have the conditions now. Look at here, I1 by I2 equal R2 by R1. Now let I by R1 equal G1 and I by R2 equal to G2. Therefore, you can say I1 over I2 equal G1 over G2. Hence, the division of a current in the branches of a parallel circuit is directly proportional to the conductance. Here, G1 and G2 are conductance of the branches are inversely proportional to their resistance. Therefore, we can write the result in word form. The division of current in the branches of a parallel circuit parallel circuit is directly proportional to is directly proportional to the conductance of the branches or inversely proportional to their resistance. Here now we'll discuss now. We know that I equal I1 plus I2. That means the current passing through is distributed as I1 and I2. So I1 plus I2 is I. Therefore, we can say from this I2 equal to I minus I1. Now dividing, that is I1 by I minus I1 equal R2 by R1, which gives I1 R1 equal I minus I2 R2. Therefore, we can say further I1 equal I into R1 over R1 minus R2. That means from this relation, that is I1 R1 equal I minus I2 R2, from rearrangements we can get I1 is this one, which is equal I into, in terms of G, you can write G1 conductivity, G1 over G1 plus G2. Similarly, I2 equal I into R1 over R1 minus R2, which is further equal I into G, G1 over G1 plus G2. Now look at this here, and only two resistance in parallel. Now if it is in three resistance are in parallel, look at here, or this, the same rule. This is I, current I, which is distributed I1, I2, I3. The resistance R1, R2, R3. The voltage is supplied from the terminal. Now the same relation we can discuss. We know that by Ohm's law V equal to IR. Therefore IR equal I1 R1. Also I can write it. V equal V1 equal I1. Now V equal I1 R1 because V equal to IR. Therefore IR you can write in terms of I1 R1. Now I by division I over I1 I over I1 I over I1 equal to R1 by R, or I can say I1 equal IR by R1 by cross multiplying, let it be 1. Now I by R, I by R equal I by R1 plus I by R2 plus I by R3, because three resistance in parallel. From this condition I is cut, then we can say by simplifying R equal R1 R2 R3 over R2 R3 plus R2 R3 and R3 R1 plus R1 R2. This is a equivalent resistance R. Now from 1, here we have I1 equal IR1 by R1. Now generally you can write I1 equal I into total current I into R2 R3 over R1 R2 R2 R3 plus R3 R1, which is further equal in terms of conductivity G1 by G1 plus G2 G3, like I2 similarly I into R1 R3 R1 R3, that is R1 R2 R2 R3 plus R3 R1, which is I into G2 by G1 G2 G3. Similarly, I3 is same I into I3 is R1 R2 here as it is. Then finally here comes I into, for I3 is I into G3 over G1 G2 G3. Like you can express the formula for each current, each branch's current. Now let us do one problem on this regarding a resistance of 10 ohm resistor is connected in series with two resistance of 15 ohm arranged in parallel. What resistance must be shunted across this parallel combination so that the total current taken shall be 1.5 amps with 20 volts applied? Here 20 V. Here 1.5 amps. 1.5 amps current is passing through. Here let it be, this is 10 ohm, and here I1 I2, I3, ohms are 15, 15 and R. Here third resistance you have to find. That points is A, B, B and current direction is like. Now we have to calculate this unknown resistance. The circuit connection are given here. The drop across 10 ohm resistor. The drop across 10 ohm resistor is I1. I1 equal 1.5 into 10 volt. So equal 15 amps. 15 volt. Sorry, here drop across 10 ohm resistor is 1.5 into 10 drop voltages. Drop voltages or drop voltage across 10 ohm resistor. That is 1.5 volt, 1.5 amps into 10 ohm resistor equal 15 volt. Here 15 volt is dropped in this. Now drop across parallel combination. Now voltage is distributed in series. Here this 10 ohm and these combinations are in series, so voltage is distributed. Therefore voltage drop across parallel circuits is, that is VAB. Here point A to B, the drop is 20 minus, already total voltage is 20, drop on 10 ohm resistor is 15, so the remaining voltage is 5 volt. This 5 volt is equal to all resistance because they are parallel. Therefore, hence the voltage across each parallel is 5 volt. Therefore, I1 equal 5 voltage over 15 total volt, that is 1 over 3 amps. The second I2 is 5 over 15, 1 over 3 amps, and I3 equal 1.5 minus 1.5 total amps, 1 by 3 for one resistance, another is 1 by 3, so which is equal by simplification 5A6 amps. So therefore I3R3, therefore I3R voltage drop equals 5 volts, or you can say 5 over 6, that is I3, 5 over 6 R equal 5, which gives drop across the shunted resistance here. R must be equal by cross multiplying 5 by 6 R equal to 5, therefore R equal 6 ohm. Therefore drop, that is this resistance shunted, must be 6 ohm. Next question, look at here. Here the battery is of unknown EMF is connected across resistance as shown in figure. The voltage across the voltage the voltage across this 8 ohm resistor is 20 volts. That is, this is 20 volts. 20 volts. What will be the current reading in the ammeter? What is the EMF of the battery? We have to find the EMF of the battery. Here, a battery unknown EMF. Here, not 20. Here, battery of unknown EMF. The voltage here, the current 8 ohm resistor, current through 8 ohm resistor. Look at this. First, we'll put it all the values here. Here, 8 ohm, 11 ohm, 11 ohm, 15 ohm, and 13 ohms. Here, voltmeter. This is ammeter. Here, this ammeter, this voltmeter, and current passes through like now. A terminals are A, B, C here. Now, current through 8 ohm resistor. Current through 8 ohm resistor. Current through 8 ohm resistance must be equal 20. Here, this is a battery unknown EMF connected across the resistance figure. The voltage across the 12 ohm is 20 volt. Here, for 8 ohm resistor, 20 volt is passing. That is 20 over 8 equal 2.5 amps. Now this current is divided into two parts at point A, two parts, this and here. Therefore, and for one part going along AC and other part along ABC, which has the resistance 28 ohm. Therefore, this is here, this together 28 ohm and this is 11 ohm. Therefore, I2, current passing through I2 equals, current I2 equal to 2.5 into 11 over 11 plus 28. Here 28 is 15 plus 13 is 28 and 11 is this side. So which is equal 0.7 amps. Now hence ammeter reading is ammeter reading is hence ammeter is 0.7 amps. Ammeter reading is 0.7 amps. Now total circuit resistance. Total resistance in circuit equal 8 plus 11 plus 8 plus 11 plus the parallels is that parallel must be getting a parallel to this one, that is 11 and 15. So that calculation is, by calculating, it becomes 10,049 by 39, which is equal 8 by 11, 8 plus 11 plus 308. 308 over 308 over 39, which is equal 1049 over 39 ohms. By calculating this, therefore, drop EMF. Here, the total circuit resistance, that EMF, therefore, EMF E is 2.5, current is 2.5, and voltage is 1049 over 39, which is equal 67.3 volts. This much voltage must be supplied to this circuit to get the required ammeter and voltmeter readings. We have done. Please subscribe our YouTube channel.